Hey guys, we're the Explorers. Today we're going to be talking about two topics, the inflationary process and the balloon analogy. For right now we're going to start with the inflationary hypothesis. The inflationary hypothesis has been one of the most groundbreaking hypotheses to come out since the Big Bang. It was developed in 1980 by a physicist named Alan Guth. I'm going to attempt to draw and show you guys what he looked like. I'm no artist. Guth's hypothesis of inflation was so groundbreaking because it may hold the key to understanding the earliest moments of the universe. He proposed that after the Big Bang, 10 to the negative 35 seconds afterwards, to be exact, the universe exponentially expanded, and then for a short time, and then stopped. This picture is a better visual representation of the Big Bang and inflation. Before Guth proposed the inflationary hypothesis, the Big Bang theory was the most widely used and regarded theory of how the universe came to be. To get a better understanding, the Big Bang theory states that at the time of its creation, the universe was hot and dense and rapidly expanding. When it stopped, everything cooled. The Big Bang theory answered a lot of questions scientists had been asking at the time, but there were some questions that still puzzled scientists that the Big Bang theory didn't answer. One of these was background radiation. Guth's theory of inflation answered the questions the Big Bang could not. The theory of inflation also supported why the temperature of the background radiation seen in the observable universe was constant everywhere. So, as stated earlier, the inflationary hypothesis that Guth proposed happened shortly after the Big Bang. He named this period of time the inflationary epoch. It lasted from 10 to the negative 35 seconds to 10 to the negative 33. Extremely short. The theory of inflation states that after the inflationary epoch, the universe continues to expand, just not as rapidly. As you can see by this beautifully drawn universe, the universe is observed to be isotropic. This means that it is the same and uniform in all directions. Now let's move on to the next topic, the balloon analogy.
Now we'll try to understand the expansion of our universe by comparing it to the expansion of a balloon. The first question that arises is that how can a universe be expanding if it's not expanding into anything? Our universe is growing into infinity in all directions, just like a balloon, except balloon is growing into air. Here, the surface of a balloon represents the entire universe, but the spaces inside and the outside of the balloon have no meaning in this analogy. The analogy works well because of the balloon's spherical structure that has no center and no edges, just like a universe. Even a universe has no center and edges. Here we need to note and remember that although our universe as a whole is expanding, the individual galaxies and clusters do not expand. This is because the gravity holds them together. Therefore, here we represent the galaxies and clusters as these red dots on the surface of the balloon, and the balloon itself represents the entire universe, which we can compare by inflating it. Now we're inflating the balloon like that. Now we can see that as the balloon is inflating, or as the universe is expanding, the dots on the surface are moving apart. This signifies the increasing distance between our galaxies due to the expansion of the universe. Thank you, and we hope that you enjoyed the video.